Math 1, this lesson's on 3.f, which is I can graph the solution to a compound inequality. Compound inequalities are extremely important for semester 2 when we get to domain and range. So understanding, one, how to graph them, but even more important, the interval notation is critical. So what is a compound inequality? It's a mathematical sentence with two inequality statements joined by and or. What we're going to do is we're going to break this up into two sections. We're going to first talk about the ands and then go and talk about the ors and then some examples. All right. So an and statement indicates that both statements of the compound sentence are true at the same time. A lot of times you will see an and statement written like this. And we read this as x is greater than A and less than B, right? And the key is to know that for and statements, right, the solution is the overlap or intersection, right, of the solution sets for the individual statements, right? So basically, it's the values of the variables that make both inequalities true. So if I gave you something like 3 is less than x, which is less than 10, I need to pick numbers that are greater than 3 and less than 4. If I take the number 6, right, 6 is greater than 3 and it's also less than 10. If I take a number like, let's say 0, is 0 greater than 3? No. So therefore, right away, although 0 is greater than 3, or it's not greater than 3, it's less than 10, but it doesn't make both true, so that would not be part of the solution set. So the graph of it is basically the intersection of the graphs of the two inequalities. So if I was to plot a number here, and then another number here, if we were to graph these two inequalities, we would look for the intersection of the two inequalities. Now, when we talk about interval notation, right, remember, our square brackets don't change, right? If we are less than or equal to or greater than or equal to, we use square brackets. If we're just less than or greater than, we use those round brackets. But for an and statement, we're basically going to have a lower bound, comma, upper bound. And again, these brackets could be different, okay? So your lower bound would be here, your upper bound would be here. Now, what about an or statement? An or statement indicates that at least one of the statements of the compound sentence is true. So when we look at an or statement, we would do something like x is greater than A or x is less than B. Okay, now this is the union, right? The union of the sets for the individual statements, which shows that the values of the variables that make at least one of the inequalities true. So there's no way to make both of these inequalities true when you have an or statement, right? So our goal is we consider it a solution if it makes one of the inequalities true. Okay, so if I look at something like x is greater than 10 or x is less than -8, right? If I pick a number, say 12, right? I know 12 is greater than 10. It's not less than -8, but as long as it makes one of the inequalities true, that would be a solution. Now, the thing about the graphs here, right? I could graph one like this. The other one would go in the other direction. This would be an or statement. And the overlapping part, or sorry, not the overlapping, the gap here, right, is why we have to use what we call the union. We want to basically say it could be this set of numbers or this set of numbers. So it's a way of connecting the two graphical solutions. When we talk about the interval notation, right, you have basically a lower bound and upper bound here. So you have a lower bound and upper bound, right? But then we put a union with the lower bound and upper bound of the other graph, okay? So let's take a look at this. Right away, anything that looks like this is considered an and statement. And we read this as x is greater than -3 and less than 9. So because I'm not equal to, I know I'm going to go to -3, plot an open dot. Now remember, x is greater than -3, so that would go to the right. If I go to 9 on the number line, open dot because it's just less than, I know x is less than 9, so we're to the left. So what I like to do is show using colors. If I'm greater than -3, I know this graph would go to the right forever and ever. If I'm less than 9, I know this graph is going to go to the left forever and ever. Where do you see the yellow and the blue intersect? You see it intersect all in between here. And this here would be the graph of your solution. So right away, I know my lower bound, and this is my upper bound. So my interval notation would be round bracket, -3, comma, 9, round bracket. It's telling me right away that it goes from -3 to 9. Some solutions I can include, some solutions to this would be any of the numbers in the shaded region. -2, -1, 0, 1, right? 2, 3, 4, all the way up to 9. Okay? The next one. I know this is an and statement, and I would read this as x is greater than or equal to -4 and less than 5. Because I'm equal to -4, I know I would go to -4, place a closed dot. Because I'm strictly less than 5, I would have an open dot. Now, x is greater than or equal to -4, so I would shade to the right. X is less than 5, so I know I would shade to the left. And where do we see the red and the blue intersect? We see that intersection in the middle here. And that would be my graph. My lower bound would be -4. My upper bound would be 5. Since we're equal to 4, it's square bracket, -4, comma, 5. We're not equal to, so round bracket. In some solutions here, you can start at -4 because you're equal to, -3 all the way up to 4. You can do 4.5 and all that also. Now the next one. I know x is greater than 0, right? So I know I'm greater than 0. So it's open circle, and I'm going to shade to the right. And I know x is less than 6. And remember, this is an and statement. Where do I see the two graphs intersect? In between here. So this is the area I would shade. My interval notation here, my lower bound would be 0. My upper bound would be 6. Because I'm not equal to, it would be round brackets. Solutions would be any of the numbers in the shaded region, 1, 2, 3, 4, 5, right? And anything between 5 and 6 and 0 and 1. Now, the next one. This doesn't happen often, but we do have to talk about it, right? So if I look at this next one, x is less than -3. If I go to less than -3, open circle, and I would shade left, right? But now the next one says x is less than or equal to 8. Well, if I read this correctly, that would also go to the left. So what really ends up being the intersection of the shaded regions? These two regions intersect from here on. So the solution to this would actually just be from here in shade to the left, which means our solution really is x is less than -3. Now again, this doesn't happen often. A majority of the time, these are the most common, but because, some of the honors kids did talk about this, I included it. So interval notation would just be, where did I start on the left? -infinity. Where did I end on the right? At -3. Okay. Number 5. This is an or statement, right? So I'm going to go ahead and graph this inequality. X is greater than 3. So it's an open circle on 3. Since I'm greater, I'm going to shade right. The next one is an open circle on -3. I'm going to shade left. Now, again, this is how all the or statements will look when I graph them. Okay? So when I talk about interval notation, right? I'm going to start it here. My lower bound is -infinity. My upper bound is -3. So -infinity, -3 round bracket. But it's unioned with, here's another lower bound, 3. So it's unioned with 3. I'm not included, so it's a round bracket. And that one goes to an upper bound of infinity. Now, solutions can be any number in either one. So I can go -12, -11, all the way up to, say, -4. But I can also include +4, +5, 6, 7, and so on, all the way up to the biggest number you can think of. All right. Now, 6. If I want to graph this, x is less than or equal to 5. I know I'm going to go closed circle on that, and I'm going to shade left. Then I'm going to go to 10, and I'm going to shade right because x is greater than 10. So lower bound here would be -infinity, 5, and it would be 10, infinity. So -infinity, 5, but that's going to have a square bracket because we're equal to, unioned with round bracket 10 because we're not equal to, all the way to +infinity. And again, any solution can exist, say -6, -5, all the way to 4. But then I can also start at 11, 12, all the way up to your biggest number. All right, number 7 here, my inequality. What you have to understand is this shaded region represents an and statement, right? So I know my x values have to be between -18 and 6. Since I'm to the right of -18, I'm greater than, I'm not equal to, but then I'm to the left of 6, so we know it's less than, because it's a closed dot, I'm also equal to. So the inequality for this would look like this. The next one, anytime I see one go to the left and one go to the right, it's a union, meaning it's an or statement, right? Therefore, when I write this inequality, this would be x is less than 9. This one would be x, since I'm to the right of 13, it would be greater than, closed dot tells me I'm equal to 13. So the inequality here would be x is less than 9 or x is greater than or equal to 13. Now let's go and look at the interval notation here. My interval notation for this one would be my lower bound would be -18. My upper bound would be 6. Since we're not equal to 18, it's a round bracket. Since we're equal to 6, it'd be a square bracket. Over here, I know I'm going to have a union, right? So from negative infinity to 9, so round bracket, negative infinity, 9. I'm not equal to 9, so round bracket. Here, my lower bound would be 13, and it goes to infinity. So 13, but that's a square bracket because we're equal to, and then infinity. And the last one we know is an or statement again, right? But it happens to be the same exact problem. So don't worry about it. All right, go ahead, try the student practice sheet, and let me know if you have any questions.